All right.
All right, for 2-6, either of 2-3 or 4. I got confused on the interval notation.
Okay. So interval notation for the domain.
Yep.
At 3, 4, question 3, question 4.
And then for 2.6, 19, 20, and 21.
All right. And 2.7.
2.7, I have 7,
Mm-hmm.
20, 25, and 26.
Okay. All right. So let's take a look at the interval notation for the so just want to point out to you that in order for us to do the interval notation, so the interval notation usually consists of infinities. This is kind of interval notations. For all the infinities, we use brackets, parentheses. If you include, we use brackets. Okay, and if you have double, you will use a union in between them. So this kind of interval notation that basic interval notation that you're looking for. So like question number 3, this is the they want you to find what is f divided by g. So if you look at this question number 3,
I can't see your screen.
oh, I'm sorry, I did not share my screen. Yeah, sorry about that. So your interval notations is going to be using infinities for parentheses, and then brackets if it's included. And then the union symbol is for if you have multiples. So for question 3D, this is the one that they want you to find the domain of f divided by g. Do you find what is f divided by g is in 3D?
F divided by G is yours the same as mine? Hold on. Oh no, yours isn't the same as mine. What is it? I got x squared plus 1. That should be the
Mm-hmm.
same. And
And then
then
the
for
square root of
x squared and then
minus 16,
minus
right?
16. Yep.
And for my case, it's 16 and over by x squared. Now, this is what we talked about last time in the Zoom. So if you see something like this, you should know the interval notation. Remember last time we did one of those examples that 16 is the perfect square of what?
4.
4. So in this case, we will use negative infinity to negative 4. And then 4 to infinity. So this is your domain in this case. Okay. So every time when you see a square root on it, on an x square, this number 16, we use the perfect square, which is 4. So then the negative 4 is included, and then 4 is, so this is how you do your domain for question 3D.
Okay.
So how do you type it is parentheses negative infinity, and then negative 4 with a bracket. And then you have a union. The union comes under set. You see a U symbol here.
Yep.
And then bracket 4 to infinity. So this is how you do the domain for this case. So so every time you see a square root, you just need to, the 16 is the one that is a perfect square. Usually the answer is either 4, 9, 16, or 25. They are perfect square numbers in this class to make things easier. The reason why that you do not need to worry about your denominator is because your denominator here, in order for us, you cannot have zeros. So, so in this case, x is 0, but you figure out that this domain, that 0 is not included here because it jumped. So if you look at the graph, it goes from -4 to the left, and then the +4 to the right. This is a domain for this case. So 0 is not included in this case, which is good. What happens if this changed to be like x minus 8? Then if you found this is x in this case is 8. So that means that 8 cannot be a part of your domain. So you will have another hole in here. So your domain, if I put x minus 8 down here, your domain in this case is -infinity to -4, and then 4 to 8. So this one has to change to 8, and then 8 to infinity. So this is what happens if your denominator, if you remember, you cannot make it 0. So that's why you will, for this case, it's good because 0 is not inside, it's not included in this domain. But let's say you x minus 8, so you have to do another one just for the 8 piece. So for this case, you will have 3 domain sets, 3 like this union that. But this, again, don't worry about this. It's not coming up in your test. I'm not going to go through this in your test. Okay, this is a bit more difficult. Same thing with 4. So for question 4, you need to do f again. We do f over g. That's always the domain for that. So in the test, I usually only want you to find the f over g domain. Do you know what's f over g in this case?
Let's see. It should be 1 over x squared, parentheses, x plus 5 for you.
So like this?
The x plus 5 is the denominator too.
Oh, this one. So let me do this again so this is the correct one. So f divided by g is, f in this case is x over x plus 5. And then you divide it by g of x, which is x cubed, right?
Yep.
And then I will change this division to multiplication, and I flip this one. So this will become 1 over x cubed. So this x and x cubed will cancel, become x squared. So your answer in this case will be 1 over by x squared, x plus 5 in the denominator, which is the same thing as the one you gave it to me, 1 over x squared over by x plus 5. This is what you told me. It's the same because this is, if you change this division to multiply and you flip the x plus 5, you will still get back this. So so how do you figure out your domain in this case? As usual, if it's a fraction like this, your denominator cannot be 0, right?
Yep.
So what makes this x, so you plug it in, you make your denominator 0. So you just need to set the x squared equals to 0. And you just need to set the x plus 5 equals to 0. So x in this case is 0.
And -5.
And -5. So that means that x in this case cannot be 0, and it cannot be -5, because if you plug that into your f over g, your denominator is 0. So if you look at the number line, 0 cannot be included. -5 cannot be included. Everything is good except these two. So how do we write this in the interval notation? So this will goes from to the left, and then you got -5 to 0, and then 0 to the right. And the reason why we use all parentheses here is because it's not included, so we don't use brackets. So how many domain pieces do we have in this case?
3.
3. So let's do the first one, this one. So how do we do the first one here?
Would it be negative infinity to -5?
And then union,
then
now the middle part.
-5 to 0?
And then the last part.
And then 0 to infinity.
Yep. So this is how we do this. So for this case, because it has two non-zero case here, so you will have 3 pieces of domain, and this is your answer in this case.
Okay.
You got it?
Yep.
Number 19. So this question is asking us to be the BT is the birth, DT is the death, and T in this case is the times since 2000. So if T is 10, it means 2010. If PT is the population of the United States, find the percent change. Now, I just know you know what is the percent change formula is. Do you know the percent change?
Nope.
So let's say if you're talking about your weight, let's say you weight last month, you go and weight yourself, and let's say it is, I don't know, 150 pounds. So this is last month. And then today you go weight yourself. This is 160 pounds, let's say. Okay. So in order for us to find the percent change, the percent change is always the difference between these two over by its original amount times 100%. Okay, this is always the percent change in this case. So if you look at this, you got the birth, B is the birth, you got D is the death, and P is the population. So how do you find a percent change in this case? You look at the difference, right?
Yep.
The difference between what? The birth, the death, the population. So as if you know, if you remember, if you want to figure out what is a percent change, you will figure out what is the birth minus the death. So that means how many people is birth will be a lot, and then death hopefully will be less. So if you subtract it, then you find the difference between those. Over by the original will be the population. And then you have to multiply this by 100 because it's a percent. So this will give us the middle one. The fourth one. Okay. Birth minus death over by population times 100%. Do you know what is C12 means?
No.
So as you know that CT is the percent change. So C12 is what? The actual or the percent change? The actual change or the percent change?
Is it the actual change?
Again, CT is represented by what?
Oh, percent change. Okay.
So this is it's written down here. CT is represented by the percent change. So this is actually a percent change. What year is 12?
20. What is it? 2010?
Well, if I say T is 10, is 2010. This is 12. So what year is this?
2012.
Yeah. That's it.
Okay.
Next is number 20, so word problems here. We will talk about the food. So in the number of bacteria in the refrigerated food is given us by the NT, 10t squared minus 20t plus 600, where t in this case is between 1 and 20. Now, what is this T stand? What is this N, capital N stands for? The capital N stands for number of bacteria. And this capital T stands for temperature in your fridge, in the refrigerator. Okay. And then when you put food in the refrigerator, the time T also correspond to your temperature, given us by 2t plus 2, where t in this case is between 0 and 6. And this little t is time. So we got 3 variables here. At capital N, which is number of bacteria, big T, temperature, and small t is time. So, so what happens is when you put a food inside the fridge, it is your food will be your food inside the bacteria inside the food is based on your temperature in the fridge, and also the temperature in the fridge is also based on the time. You know, the longer the time you put in the fridge, the colder the food, the bacteria will getting less, because when it's cold, the bacteria is not active. So this question is asking us to find N dot TT. And what is N dot TT? Sinu?
It would be 2.
Taking,
It would be 2, and then everything from the NT.
so you're taking the TT and plug it into where?
Into N.
To the N. So we got TT here. This is TT. So we take this 2t plus 2, and what do we plug?
We plug it into the N. So 10, and then
To this capital T, right? So it will be 10 squared minus 20 plus 600. So what is the T now? It will be replaced to
2t plus 2.
So this is the meaning of N dot TT, means you plug this TT to your NT. Now you need to expand it. So this you need to FOIL. So what is 2t plus 2 squared? We need to do this one first.
4t squared plus 8t plus 4.
Very good. And then you need to multiply this by 10. So you multiply this by 10. What'd you get?
It'll be 40t squared plus 80t plus 40.
And make sure this t is a tiny t, not a capital T. And then distribute your negative 20 here.
And then it'll be negative 40t, and then negative 40.
And then the plus 600. Then you combine the like terms. So it's 40 t squared minus 40t, because 80 minus 40 is 40. Positive, sorry. That's positive 80, take away 40. This 40 and this 40 is cancelled out, because then you just have 600. So this is your answer for part A. Okay, so this one. And then the question is asking us, what is N dot TT means? Now remember, this NT is the number of bacteria based on temperature, right?
Yep.
But what is this N dot TT means?
What is it? It represents the number of bacteria in the food as a function of time.
Yep, time. Yes, in time. So that is the first one. Yep. Not the rate, but it's the number of bacteria. Okay. And then you need to figure out what is the bacterial count after 0.5 hours. So for part B, what you do here is you just replace your T to become 0.5 and substitute inside here. So you will find n dot T 0.5. These are unique calculators. So just put 0.5 inside here. It will be your answer. I think you can do that, right? Sinu?
Is it for mines? It said that my answer was off.
Do you know what is your n dot TT is? Because it's not the same as this one.
Mine is 160
T squared?
T squared plus 80 T plus 500, and then I had 0.5.
You also got 0.5. Okay, put 0.5 in there, and what do you get?
I got 3,740.
Let me check. Plus 80, but this one is correct, right? The function n dot tt is correct, right?
Yep, it's correct.
Okay, because if that is wrong, then no, I don't get 3740.
Oh.
Do you take the square of this?
Yep, I squared it first.
You can, if you have a you can type this whole thing in your calculator.
Oh. I tried doing it one by one.
Try it one more time. It's not 3740.
Okay.
I can tell you, it's not.
Okay, I got 580.
Yeah, that's correct. This is okay. Then the next one they're asking you is find the time when the bacteria reached 2000. So what is going on is we're still gonna use this formula that you get in A. Last time we plugged in T as 0.5, but now you will plug in n dot TT as 2000. So this will give you 2000 equals to 40T squared plus 40T plus 600. So what happens in question C is they will make this equals to 2000. That's how many bacteria they want. So in order for us to solve this is this is a quadratic, so you have to make it equal to 0. So you have to subtract 2000. So you will get 40T squared plus 40T minus 1400. That's 600 minus 2000. And then you need to reduce this. This you don't do your quadratic equation here because it's very difficult. So I think it can be reduced by 40. Let's see if I can reduce by 40 or not. Yep. So this whole thing can be actually reduced by 40. So you can divide everything by 40. So your number is so much smaller. So it's T squared plus T, because when you reduce by 40, this 40 and 40 is gone. So this will give me negative 35. So this is usually what I do first. And then with this, I can use my quadratic formula. I don't think so you can factor this. No, because it's 35. So negative B, so it's negative 1, plus minus square root of B squared, which is 1, minus 4A, which is 1, and C is negative 35, all over by 2A, 2 times 1, which is 2. So this will give me negative 1 plus minus square root of, if I do this one you can drop it because anything multiplied by 1 is the same. So 1 minus 4 times negative 35. That is 140, I believe. Times 141, right? So 1 minus 4 times negative 35. That is 141 over 2. Then what you need to do here, because your answer is in, they want it in decimals, round your answer into 3 decimal places. So so what you do is you take the square of it. So so if you take negative 1 plus square root of 141, and then you divide this by 2, you will get 5 point something. So when you do the plus sign, you will get 5.437. This is for the plus sign. And then you do the same thing for the minus sign. So you get negative 1 minus square root of 141, and then divide by 2. So that will give me negative 6.437. So unfortunately that this time is only measured between 0 and 6. So the only answer you can give it to me is this one, because this is the number that is between 0 and 6. The negative one, you cannot take it because it's not in the range, in the domain here. So your answer in this case is 5.437. You okay here?
Yep.
So this is how you figure out this question. So make sure you you have to use quadratic formula to do this. But when I recommend you to reduce this first, because it'll be smaller to do your quadratic. Otherwise, your answer is your answer is still the same, but you're using big numbers to play with, which is a lot more difficult. So this is how we do question number 20. And for 21, it's another word problem. So it's talking about cost. So the cost of manufacturing is given us by the function of Cx equals to 50x plus 750, where C is the cost and X is the units produced. And this unit produced is also based on time, and it is 60 T. And T in this case is hours. So this question is again is asking for C dot xt. This is very similar to what we just did just now. So how do we find C dot xt in this case? This one is, how do you find C dot xt?
So you'll plug in the xt into the C formula?
Yep. So you will get 50 times what?
50 times 60t
Plus
750.
50. Can you, what is 50 times 60?
300.
3,000.
3,000, yeah.
And then 750. So this is the answer for this one. This is A. And what is C dot xt stands for? C stands for what?
The weekly cost of producing.
And T is?
T is the hours.
In time, right?
Yep.
So which one you think is represent productions as a function of cost, or cost of a production as a function of time?
Cost of production of time.
Yep, so it's the second one. And then the same thing happens here for part B. They want you to find what is the cost in 4 hours. So you just need to plug T to become 4 here. That's easy, right? This one is easier because it's not square.
Yeah.
So you plug T to become 4, and then your answer will be whatever you get. C, find the time. So the cost is increased to 15,000. So this is the same thing what we just did just now is we just need to change this to 15,000. And then you got 3,000 T plus 750. So you just need to solve for T here. Again, you do not need to use quadratic formula here because it's not squaring. So you just subtract 750 and then divided by 3,000.
Okay.
Because they only got 3,000. So if you take 1,500, this is easier than the previous one, but it's the same concept. Divided by 3,000. So you get 4.75. You okay there?
No.
So this is a bit easier than the question 20 because it's not squaring. Once it's square, you got a little bit tough. Okay. Are you all right?
Yep.
Okay. Next, we're going to talk about 2.7, question number 7. So, so when you do the inverse function, they want you to figure out f of x. So they want you to figure out what is the inverse function in this case. So do you know how to find an inverse function?
Hold on.
There are a few steps you need to do when you find the inverse function. Step 1, you have to interchange your f of x and x. So what do I mean here is f of x will become x. X will become y. I usually do not want to do, f of x is the same thing as y. So I just want to do just interchange. This is the first step, you interchange that. So interchange your variables. And then second step is to solve for y. So how do you solve for y in this case is I divide this by 5. And the last step, there's only 3 steps, change your y to become f of inverse of x. So your answer in this case is this y will change to become inverse x over 5. So this is your inverse function. So these are the 3 steps. Make sure you know these 3 steps. These 3 steps is to change your inverse function. Change your how you find your inverse function. Now, there are some rules that you need to know when you talk about inverse function. One of them is if you want to prove this is the inverse function of that, you figure out that if you do the f dot f minus 1, you will get x back. And if you do f inverse dot with f, you also get x. So this is one of the way to check if this is the inverse function of that, is you do the dot. So this question is asking us to do f inverse of x. So what does that mean here is I take the inverse of x, because it's over here, and I plug it back into your x. So what is going on in here is f of the inverse of x, in this case will be x over 5, because that's my inverse of x. So what you do is you take this and plug it back inside your x. So it's 5 times x over 5. So mostly it's kind of like the dot product that you guys did in last section. Okay. So this is the f dot f inverse. Now the 5 will cancel, you end up with x. This is what we usually want, because that is how you figure out it has to be equal to x. And now you do the f minus 1 dot with f of x. So that means that now you do the opposite. You take the f of x and plug it back into the inverse. So, so the f of x in this case is 5x. And you plug it back to the inverse of it. So the x in this case is 5x. You plug this inside x. So what is over here is 5. Because if you plug the 5x into here, it's 5x over 5. And the 5 will cancel and you get x in this case. So this is that's why you need 2.6 in order for you to do 2.7, because it does do composition functions. So make sure you know this is more important actually. If you tell me which is more important, the 3 steps that I showed you is more important than showing. Usually, if you have time in your test, then you just do what you did here to show that to verify that this is really the inverse of f of x. This is how we do it. Same thing happens to question 8. The good thing is g of x is given to us. So you just need to plug this inside here and you notice that it came up with x in this case. So this is the inverse function, which is very important in this class and in trig. So when you go to next class, it's very important. Next we'll talk about here is number 20. So again, it's asking us to find the inverse of x here. So we're gonna use back the same procedure, the 3 steps procedure that we have. So it's given us that f of x equals to x squared minus 7. And x in this case is less than or equal to 0. So this x is less than or equal to 0 is what we call as a domain restriction. We call domain restriction. So it's a restricted. The reason why is because if you know x squared minus 7, the graph of x squared minus 7 is a parabola that goes down to -7. This is x squared minus 7. Another way that we can figure out that this x squared minus 7, it does not have an inverse function. The reason why is because it fails the horizontal line test. Because when you draw a horizontal line test, you can only intercept on the graph 1 time. So if you intercept more than 1 time, like this case, it does not have an inverse function. That is very important. So what we do here is we do the domain restriction. That means we only take x value that is less than or equal to 0. So that means we are only taking this part. And we will not take this part. So that is the meaning of the domain restriction here. And with this domain restriction, this graph only intercept 1 time, and it will have an inverse function. So that's the reason why that this is very important. If you found a function does not pass the horizontal line test, means like the one that I just did over here, we will have to do what we call as a domain restriction, means we will restrict into 1 piece. At that piece, it is a function. It has an inverse function, means it passes a vertical line test. This piece is very important, is because it has a plus and minus sign. So can you tell me when I say x is less than or equal to 0, is that for positive or negative?
That's negative.
Yep. So just put this in mind that when you do the 3 steps here, they will have a plus minus and you have to pick the correct sign. This domain restriction will tell you, because this is negative, if I domain restrict it from x is greater than 0, means I take this side, then we are talking about positive. Okay, so this is quite important here. So again, what we do here, first step, interchange your f of x and x squared. So this will become x, this will become y. And then second step is you solve for y. So I move the 7, -7, become +7. And then I take the square root because there's a square here. Now, every time when I take a square root, you need to have a plus and minus. So this domain restriction will comes in handy. What sign do we use? So what sign should we use here? plus or minus?
Minus.
Yep. The reason why you use minus is because your domain restriction is taking negative. So we put minus. And then the third step is you just need to replace your y to become the inverse of x. So what is your answer in this case?
Negative square root x minus 7.
Negative square root of x minus 7. Yep, that's correct. So this is x plus 7, right? Oh, sorry. Yeah, this is x plus, sorry, because there's a plus here. So it's x plus 7. So I just want to point out to you that everything is the same except this domain restriction will pick him. Okay. So what happened is we already draw the graph of x, the function of x, which is the orange line. So can you draw me this function? The inverse function. What kind of transformation do we have?
The inverse function will start off on the x line and go right.
So this is the original square root. So what is this plus 7 means? If you remember your transformation.
It means
Up, down, left, right.
it means to go right.
Don't forget, it's always switch.
Oh, left.
Left 7. So this graph will go to left 7. So now it will be at negative 7. And then what is this negative in front means?
To go down.
It's a reflection on the x-axis. So it will go down like this. So your graph will be at, for the inverse function, will be at negative 7. And it will go down like this. So which graph shows you these two? The main point here is what? This is on negative 7 and this is on negative 7, right?
Yep.
So which one is the correct one?
It would be the top right.
This one?
Yep.
Well, this is negative 7. Yep, this is negative 9. Yep, and the line, and when you draw me the y equals to x, this they will, if you fold it into that yep, this is a correct graph. Yep. And what is the relationship is it will be reflected on y equals to x. So your answer for this, if you draw the line, this is what the purple dot line you see here is called a y equals to x line. So it is the reflected of that one. Okay. Domain and range. So what is the domain of the original function? Because it is given us by this domain restriction, then you have to follow it. So what does it mean by x is less than equals to 0? What is the domain?
So negative infinity
to
0. And then
so negative infinity to 0. That's correct. Okay. Now, I do not know you know this. Another property of 0 is included because of the equal sign. The very important property here, Sinu, is the domain of the original function is the same as the range of the inverse function. So what happened is the domain and range of this original function is the opposite of the domain and range. That means you flip-flop around. So the domain of this is the same thing as a range of your inverse function. So you just, if you know the top one, you just need to do the same. You just flip it around. You know what I'm trying to say here, Sinu?
Yep.
So this is a very important property. Now let's talk about the domain, the range. So if you remember your orange graph here, what is the range of this orange graph? The y value.
The range will be bracket -7 to
to infinity, right?
Yep.
So this will be from bracket -7 to infinity. And then that will be the same as the domain of your origin of your inverse function. So this will be the same as the range of that. So very, very important property here. So make sure you understand this. This is one of the most important property of inverse function. They switch around. You got what I'm saying here, Sinu?
Yep.
Next is 25 and 26. 25 is this. Yes, this is good. Question 25 is coming out in your test. So please pay attention. So this question first is asking, is this has an inverse function? Okay. So in order for us to figure out if this has an inverse function, there are a couple of ways to do it. One way is to draw a horizontal line test and see if you intercept at one point, like what we just did just now. But since this doesn't give us any graph, we cannot do it. So we cannot figure out. I mean, if you know how to draw this graph, which you will learn in chapter 4, then good. But since we do not know, then it has to be one-on-one. So there are two ways for us to figure out. So since this is not providing us graph, so we figure out one-on-one. One-on-one, what is one-on-one means? One-on-one means that if you put one x value, you will get one y value. That's the meaning of it. So you don't have two y values or three y values. So that means that when you plug x to be any number, your y answer only have one. For example, if you plug x here to become 1, what is your y in this case? If you plug x to become 1. So this will be 1/9, because 4 minus 3 is 1 and 5 plus 4 is 9. What we have is 1-to-1, means this is 1-to-1 because one x value, you get one y answer. Okay, you don't have a plus minus, so you have no two answers. And if you plug any number you want 0, you will get, so when x is 0, this is -3 and this is 5. You also get 1-to-1. That means that you only get one answer in this case. So for this case, yes, it does have an inverse function. The reason why it has an inverse function is because it passed the 1-to-1 test. Okay, the one that is not 1-to-1 test is when you plug something inside, you get two y answers. For example, is like x minus 3 and x plus 4. And if you plug this, becomes 0. When you plug x equals to 1, you got two y answers in this case. You will get that means so when you plug x is 1, you get two y answer. One is -2 and one is 5. So this is not 1-to-1 because you got two y answers. So just want to point out to you guys that let's put 0. That's better. You got two answers, 3 and -4. So so what happened is that make sure this is not 1-on-1. Okay. So this is a way that you guys prove if it's 1-to-1, is plug any x value you want. If you get one y answer, it's 1-to-1. So the next question that asks you in this case is figure out what is how you find the inverse function. So again, we use back the same 3 steps. Interchange your y and x. And then solve for y. And then write your y to become f of inverse of x. This is the same 3 steps, okay? So how do we figure this one? Is first interchange all your y to become x, and then all your x become y. So this is the first step we do. Now this is difficult because now you got two y's. Last time you only got 1, this time you got 2. So how do you use the second step is you have to solve for y. So how do you solve for y is we don't want the denominator, so I multiply it to this side. So I will get x 5y plus 4 equals to 4y minus 3. And then you distribute your x, so you will get 5xy plus 4x equals to 4y minus 3. So this is where this is what a lot of students doesn't know what to do here in the test, is then once they multiply in, they distribute, they don't know what to do next. So when I want to solve for y, I want all the y terms on the other side and all the non-y terms on one side. So what do I mean here is this is a y term, so I will move this y term to this side. This one has no y term, I will move it to the other side. So like solving equation, so when you 3x plus 2 equals to 2x minus 5, when you solve this equation, you want to move all the x on one side, so that's why you subtract 2x here. And then you want to move all the 2 over there. So this is what happens, the same thing is because you want to solve for y, we want all the y's on one side and all the non-y on the other side. So when you do this, you got 5xy minus 4y, negative 4x minus 3. And then the main part here is because they all have y terms here, you can factor the y out. So you will get 5x minus 4. And you will get negative 4x minus 3. And then since this is, then you divide. So you divide this with this fellow, 5x minus 4. So this is how you figure out how you solve for y in this case. It's quite a bit of procedure here. So, so then you change your y to become the inverse function. So the inverse function in this case will be negative 4x minus 3 over by 5x minus 4. So this is the inverse function in this case. You all right there, Sinu?
Yep.
So make sure you take a picture of this question number, what question is this? 25, this one. Because this, as I mentioned, is in your test on, your coming up test here. So make sure you know how to find it. 26 is the same thing as, is that number 20 that we did? This question 20. 26 is the same thing. You have a domain restriction over here. Last time the domain restriction is less than, we take the negative, if you remember that. Now the domain restriction is greater than, so you will take the positive. And how do you find the inverse function? You just follow the same steps, same 3 steps here. So change your f of x to become x and change your x to become y. So this is the first step. Second step, solve for y. So we need to get rid of the square first. So we square root both sides. So should we take the plus or the minus based on the domain restriction given to us?
Plus.
Because
it's greater than positive 4.
Yep, so it's greater than, so we take the plus. So this is a plus square root of x. The square and square will cancel, you get y minus 4. And then remove the negative 4 over. Now, when you move the negative 4 over, become positive 4, the positive 4 is outside the root. Okay, it's not like this. This is wrong. Okay, it will be this. What's the difference? If you look at transformation, plus 4 like this means you go what? If you remember transformation. This one means you go up 4. But if you draw a line across like that, then it goes what?
Left 4.
Left 4, yes. So different. So please make sure when you move the 4 over for this case, it is not inside the root. And then the last thing is you just change your inverse function to become f of y to become the inverse function. So this is your inverse function here. And then find the domain and range. So if you remember x minus 4 squared, do you know it's a parabola? Do you know what is this minus 4 stands for?
Is that the, what is it, the starting value?
Yep. So what kind of transformation is that when you put a minus 4 like that? Left, right, up, down.
What is it? Down?
Don't forget, down means it's like this.
Oh, then right.
So this is right 4. That means you take this whole thing and move to the right 4. So it goes like this. But because it does not pass the horizontal line test, so it restricts the domain from 4 till infinity. So we do not want this piece. So we only take from 4 to infinity. So what is the domain for this piece?
Bracket 4 to infinity.
Yep, following the domain restriction. And what is your range in this case?
Would it be bracket 0 to infinity?
Yep. So this is how you do your domain and range. And what happens to the domain and range in the inverse function?
The domain becomes the range, and then the
Yep.
range.
So flip it, right?
Yep.
Yep. So that's how you do this question. So it's not difficult. Make sure you know why we learn the transformation and the composite function first before we do this. It's because you need to know all this before you move on to this one. Okay.
All right.
All right, so this is your homework here. So we will talk about 3.1 because your next homework is 3.1 and 3.2. So what is in chapter 3? Chapter 3 is where we talk about polynomial functions. So if you remember last time doing polynomial functions, we started with, so in 3.1, we start out with quadratic, means x squared. Ax squared plus bx plus c. And then 3.2 and 3.3 and 3.4, we will do x cubed, x4, x5. So the more higher the power, the more difficult it gets. Okay. So so right now we are doing a polynomial, a quadratic function, which is ax squared plus bx plus c. This is called the quadratic function. So this we know is a parabola. And every time when you draw a parabola, it has what we call as the axis of symmetry. Axis of symmetry is where you cut the parabola by half. And these two are reflection to each other. This line that I draw, the red dotted line, is called the axis of symmetry. And the one that goes way below here is what we call as your vertex. So your vertex is what we call as your turning point. You only got one vertex. And if you got this vertex is minimum. And you can also have a parabola going this way. And this vertex will be your maximum. Okay. How do we know it is minimum or maximum? It depends on your A. If your A is positive, you will get the minimum, like this. If your A is negative, you get a maximum. So, so this depends on your A here. Okay. So we call this open upward because it's going up. And then we call this open downward because it's going down. So this is the A part. Your A is also important for stretching. So if your A in absolute value is greater than 1, it's gonna get narrower. That means that if this is a equals to 1, it's like that. A equals to 2 will be getting narrow. A equals to 3 even narrower. So the higher the A is, the A number is, you will get narrow. What happens if your A is between 0 and 1? Then you will get wider. So for example is if you have 1 is the black one, then this red one will be A is 0.7. And the purple one is A is 0.3. So the more smaller the A value, the wider it gets. Okay, so this is the some basic stuff of quadratic. So however, you can, if I give you this quadratic function, you can only figure out if it's open wider or open narrower or open upward or open downwards by looking at your A. But you cannot find your vertex here by looking at this. You can use the formula. So what you need to do is you have to transform this into this formula. And transforming this is called a standard form. By transforming this into this formula, then you can tell me your vertex. Your vertex in this case is HK. And don't forget the sign here is now minus and the K here is plus. So what is going on is that once you know your vertex, your turning point, then you automatically know your axis of symmetry, which is this dotted line. Your axis of symmetry is always x equals to h. Whatever you found in the h coordinates in your vertex, that is your axis of symmetry. So the question is, how do we transform from this quadratic function to a standard form? There are two ways to do it. One, you perform completing the square. Two, you use the vertex formula. Now, which one I strongly suggest you to do? Definitely using vertex formula. Because if you do completing the square, it will take you 5 steps to do it. And it's going to be very, very tough. So the only thing about vertex formula is you need to know the formula. If you do not know the formula, like quadratic formula, if you doesn't know it, you're probably pretty screwed, you doesn't know how to do it. So what is the vertex formula, which is right here? This is the vertex formula. Is negative b over 2a and f of negative b over 2a. So this is your h and this is your k, and your a and your b is this is your a and this is your b. So the c is not a very important key here, but you will figure out we also need c when you do it. What is this f of negative b to 2a is once you find this, you just substitute back into your function, okay? And once you get into your vertex, then we can write this in a standard form, okay? I'll show it to you what does that mean. And do not do computing the square. So when you do your homework 3.1, when you watch the video will show you how to do completing the square, which is like a lot of work, okay? But then you can actually use the vertex formula to do it. So, so can you, like this question, number 7 here, can you tell me what is your, this is already in a standard form. So what is your h and k in this case? If I give you this, x plus 4 squared minus 2, what is your hk, your vertex? So if you look carefully here, your h has to be minus. So what happens if this is plus? You have to switch the sign. So what is my h in this case? It will be negative 4. K is plus sign, but if you have minus sign here, that means also you need to switch around. So your k in this case is -2. So your answer for this is going to be this because your vertex is at -4, -2. So you know you're okay?
So for the k, even though it needs a positive, it's still okay with the negative.
Yeah, but then you need to put negative.
And then for the h, regardless, it needs a negative, right?
Yep, if it's a positive. So if I give you x minus 3 squared plus 2, then my h will be +3 and my k is +2.
Oh, okay. So it's like,
So it has to be minus and it has to be plus.
okay, this makes
But
sense.
what happens if I give you x minus 3 squared minus 2? Then what is my vertex here?
It'll be 3 and then -2.
Yep. And if I put a plus in here,
Then -3, -2.
yep. So this is something like this. So can you tell me by looking, oh, not this one, okay, this one is a little bit funky. Okay, so like number 8, the reason why I say it's a little bit funky here is because they like to trick you guys. So this 3, actually, I can move it backwards. So remember when I say 2x plus 3, I can also write this as 3 plus 2x, right? They are the same. So this 3, I can move it back. So number 8, the function actually looks like this: -x minus 1 squared plus 3. So this 3 you see here can move back. So can you tell me what is your vertex in this case?
Would it be 1
And
then 3?
yep, so your vertex will be 1 and 3. But this negative, if you remember, what happens when your a is negative?
It goes to the right.
No,
It,
it goes downward. So this graph, this negative means your parabola will go what?
go
Upside down.
Yep.
Okay, this negative is the one. So which one is your answer in this case?
the bottom.
Left or right?
The bottom left.
Yep, maybe at the bottom left because it's 1, 3 is the vertex, and it's been the negative is the one that makes it open downwards. Now the next one is asking number 9 and number 10. They're asking you to write this in a standard form. So when they ask you to write this in a standard form, means they give you the quadratic function form. They want you to write in the HK form like what you just did over here. Again, as I mentioned here, there are 2 ways to do it. One way is using the computing square, one is using vertex formula. So I would recommend you to use the vertex formula. So I'm going to show you to you what is the vertex formula is. So it's given us that f of x in this case is x squared minus 6x. So using the vertex formula, the vertex formula says that negative b over 2a, f of negative b over 2a. So our a in this case is 1 and our b is -6. So in order for us to find the negative b over 2a, b in this case is -6, so 2 negative will make it +6. And then 2 times a is 1, so 2 times 1 is 2. So this is actually 6 over 2, which is 3. This 3 is your h. Remember your vertex is 3. Now, how do we find your k? It's very easy. This stands for plugging what you have here into your x. So what is f of 3 is? So plug 3 in here, you get 3 squared minus what?
-6 times 3.
6 times 3. So this is 9 minus 18, which is -9. So that is my k in this case, -9. So this is the fastest way to find hk if I give you the quadratic function. But how do you write this in the standard form? So standard form is where you use a x minus h squared plus k. So what you do here is you take, this is your h, this is your k, and this is your a. Don't forget, this is your a. Same a, plug it over here. So the function in this case will be, now a is 1, so we do not need that. X minus h is 3. Don't forget the square. And then plus k is -9. So this answer is this. X minus 3 squared minus 9. So this is the quickest way for us to find the standard form and the vertex. If you do completing the squares, you are still doing it right now, halfway done. So that's the reason why that I do not suggest you to do the completing the squares. So can you tell me which graph is correspond to the vertex 3, -9? Top, bottom, left, right.
3 and -9.
Yep, 3. Just figure out the coordinate 3, -9. Where's 3, -9? At what quadrant?
It would be quadrant
1, 2, 3, or 4.
2.
Mm.
Wait.
3, -9.
Quadrant.
Coordinates.
No, quadrant 3 is negative.
This is 3.
Quadrant 4.
Quadrant 4. Yes. So which point here give you quadrant 4? Turning point.
The first one. The top left.
The vertex is 3, -9. So you if you do the vertex formula, the vertex is already given, already found. Now when you do axis of symmetry is the first h value, 3. So a lot of students do this in the test or in your homework. They put 3. Oh, because your h is 3, so you put 3. Your homework will mark you wrong. The reason why is because axis of symmetry is x equals to 3. So make sure you do that. A lot of students will ask me why I put 3 is wrong, because axis of symmetry is a line, not a point, not a number. So in the test, I will take half a point if you do not put x equals to 3. Okay. Now, how do you find your x-intercept? So in order for us to find your x-intercept, you will set your function equals to 0. And you solve for x. Do you know how to solve for x here? You move the -9 over, become 9.
And you square root it.
And then you square it. And every time you square it, you got how many answers?
2.
2. So what is square root of 9?
Plus or minus 3.
Yep. So you got x minus 3 equals to +3. And x minus 3 equals to -3. So what is this when you solve for x here?
0.
This is 0.
No. Yeah. That one's
And
0
this
and then that one's 6.
6. Now, because if you read, this is your answer here. But if you read the question carefully, they want this in what form? Coordinates, and they want the smaller. Which one is smaller here, 6 or 0?
0.
0. So that means you will have 0, 0 for the smaller one, and 6, 0 is the larger one. So this is your this is how you figure out your x-intercept. Is you put this function that you found in becomes 0 and then solve for x, and then your answer has to be in coordinates. You put the smaller one first, then the larger one. So this is how you do this. You all right here?
Yep.
So majority of question, this 3.1 homework is all the same thing. They want you to write this in the standard form. So what you do is you do the negative b over 2a first to find your h. And then after that, let's say you got 3, then you do f3 to find your k. And then your a is still the same a as your original. And then you plug this into the standard form equation where your a will go in the front, your h is in here, and your k is in there. And then they will ask you to find the y in at the x-intercept. You just set this whole thing equals to 0 and solve for x. Now, if you have, because our graph is this, so sometimes you can look at it and you can tell the x-intercept because it intercept what value? 0 and 6. So that's why your answer is 0 and 6. So if you sometimes you can eyeball from the graph. You do not need to work on this. So it's 0 and 6. Do you know what happens if you have a graph that goes like, let's say you pick this graph. Do we have any x-intercept? Let's say this is your graph and it's correct. Do we have any x-intercept here? We do not, because this graph do not cross on the x-intercept. So if it does not cross, you just put D and E. Okay, so if that doesn't do, you just put D and E on it, capital D and E. This is what happens when your graph is like above or your graph is below the x-axis. So it never crosses. So let's say this is your x-axis, your graph is below it. So this one, your x-intercept will be D and E also. Same thing if you go on top here, this is D and E, because it will not. And what happens if it crossed, it was touching like this at -4? Then how many x-intercept do you have?
1.
You got 1, which is -4 with x-intercept. Okay. And the last one that we did, it crossed twice. So that's why you got 2 x-intercept. So the graph tells us quite a lot of stuff when you talk about x-intercept. So make sure you know how the graph looks like. You all right here? Yep. So this is 3.1. 3.2 is where we begin to do graphing. So when you do 3.2, we do a you might have to this 3.2. The graph is a polynomial graph. So if I give you x cubed plus whatever I want, this graph will have what we call as end behavior that looks something like this. Because if you remember x cubed graph is like that. So it goes up and up. Same thing happens when I go from x cubed to x5, x7, x9. I don't care what is behind it. Your end behavior will look something like this. Now, what happens if you have a negative in front? Then if you remember when you put a negative, your graph will be reflected like this. So your end behavior will be going up here and down. And again, I don't care if this is 3, 5, as long as this is odd. What happens when this is x squared plus something? We know that this is a parabola going upwards. So that means your end behavior is both going upwards. This works from 2, 4, 6, 8, the even ones. But make sure this is positive. Okay, this also has to be positive. The leading coefficient is positive. And what happens if you have a negative x squared? We know when you see negative, your parabola open downwards. So that means both of them goes down. And again, this is work for 4, 6, 8, even ones. So so make sure this is called an end what you call this is called end behavior. So that is the first thing you need to know is end behavior. what is that open up? Is it going up, down, or up, or down, down, or something like that? And then the next thing you need to know is how many turning points. Turning point is this. So this one has 3 turning points. So how do we figure out turning points? Is you take the degree minus 1. So if you have power 4, x to the power 4, then you will have 3 turning points. It will look something like this. So this graph is actually x4. Okay. If you have x squared is a parabola. You only got 1 turning point. If you have x cubed, you got 2 turning points. So the turning you cannot see from here, but usually when you have x cubed, the turning point will be like this, where you will get 2 of them. Okay, so this is called the turning points. Then the last thing we'll talk about is multiplicity. So multiplicity is where you get, let's say a number here, to the power of n. Okay, so if this n is odd, we call odd multiplicity like 1, 3, 5, 7, then it will cross at this number. So let's say if this is a -7, it will cross at 7. Now, when I say cross, it can cross this way or it can cross that way. Okay. Now, if it's a direct crossing, the power here, your n here will be 1. But what happens when n is 3 cubed? Then this will cross like a cube function, or it can cross this way, depends on what. And what happens when n is 5? Then it will be more, it will cross at 7, but more flatter. So here is more flatter than cube. So when you have 1, it crosses exactly like a straight line. When you have cube, power 3. When you have power 5, this is flat. If n is 7, this is even flatter than 5. So this is when this n is odd. What happens when n is even? So you will touch. So this one is cross, like you cross straight away. And when you have even, it will be touch. So what happens, this is the last thing we'll talk about, is at 7, it will, if it's even, it will be touching it when n is 2. What happens when n is 4? It will still cross at, it will still touch at 7, but it will be flatter down here. So the more power you have, the more higher the power you have, the more flatter. So if you have 6, this is even flatter than 2 and 4. So this is what happens when you have what we call as multiplicity, means you take x minus or x plus 7 to the power of n. And this n is what we call as multiplicity. The -7 means it crosses at +7. A +7 means it will cross at -7. So this is the only difference between if you have a negative or positive. If you have negative, it will be on the positive side. If you have a positive, it will be on the negative side. And then it depends on your power here. Either they're odd or even. Odd, it crosses. Even, it touches. So that is mostly 3.2 materials that we talked very briefly. So so your next homework is 3.1 and 3.2. I will post some videos, so please watch them. Again, if you have any questions, let me know. Your first test or midterm test is 2 weeks from today. It's going to be in class. I also will send more information to your email so everyone knows your test is in 2 weeks from now. And it does cover chapter 2 and chapter 3. Chapter 3, we got 3.4, 3.1, 3.2, 3.3, 3.4, and that's it. So that will be your chapter test, and I also will give you the review. So probably tomorrow you will get that. So please check your email to figure out the your test information. Questions for me?
No, that is all.